Have you ever wondered how C++ programming works? What makes it unique and why it is so widely used in the world of programming? In this video, we're going to unravel the mystery of C++, from its history and development to its characteristics and its pivotal role in object-oriented programming. We'll explore how C++ is a universal, efficient, and machine-near language and discuss its portability across various platforms. We'll also delve into its object-oriented programming features like data abstraction, data encapsulation, inheritance, and polymorphism. And not to forget, we'll explore the extensions added to C++, such as references, templates, and exception handling. These are just a few of the topics we'll be covering in our journey through the captivating world of C++. So buckle up and get ready to dive into the fascinating world of C++ programming. C++ didn't just appear out of nowhere. It has a rich history that dates back to the 1980s. This potent programming language was the brainchild of Bjarne Stroustrup and his team at Bell Laboratories, which was a part of AT&T in the United States at that time. Stroustrup's objective was to create a language that could efficiently implement simulation projects but with an object-oriented approach. This led to the earliest versions of what we now know as C++. Initially, it was referred to as C with classes, a name that clearly hints at its origins and initial intentions. The name C++ is not random, but rather a clever nod to its predecessor, the C programming language. In C, is the increment operator, symbolizing that C++ is an enhanced or incremented version of C. As the language began to gain traction, there was a need to standardize it to avoid confusion and inconsistencies. Thus, in 1989, an ASI committee, the American National Standards Institute, was formed with this very purpose. The goal was to bring together as many compiler vendors and software developers as possible to agree on a unified description of the language. The efforts of the ANSE committee culminated in 1998, when the ISO, the International Organization for Standardization, approved a standard for C++ with the designation ISO/IEC 14882. This was a landmark achievement that firmly established C++ as a globally recognized programming language. The development of C++ was a meticulous process, involving numerous software developers and experts. It was not just about creating a new programming language, but about enhancing an existing one and amalgamating it with the concept of object-oriented programming. It was about creating a language that was universal, efficient, close to the machine, and portable across various platforms. Thus, C++ was born, a powerful language that combined the efficiency of C with the advantages of object-oriented programming. So, what makes C++ stand out? What are its unique characteristics? Let's dive in. C++ is universal, a trait that allows it to be used in a wide array of modular programs. This universality contributes to its popularity as a programming language, making it a common choice for various applications, from game development to financial modeling. Being efficient and close to the machine are two other hallmarks of C++. This means it allows for a level of direct control over the hardware that many other languages can't match. It's like being able to speak directly to the computer's core, allowing for precise manipulation and efficient execution of commands. Now, let's talk about portability. C++ programs can be written once and run on various platforms with little or no modification. This is a huge advantage, especially when developing software intended for multiple operating systems. However, what truly sets C++ apart is that it is not a purely object-oriented language, but a hybrid. It contains all the functionality of the C programming language, which means that large quantities of existing C source code can also be used in C++ programs. This hybrid nature allows developers to choose whether to use procedural or object-oriented programming as the situation demands, providing a high degree of flexibility. C++ supports the concepts of object-oriented programming, which include data abstraction, data encapsulation, inheritance, and polymorphism. Data abstraction is about creating classes to describe objects, while data encapsulation allows for controlled access to object data. Inheritance involves creating derived classes, and polymorphism allows for the implementation of instructions that can have varying effects during program execution. C++ also has added language elements such as references, templates, and exception handling. These elements, while not strictly object-oriented programming features, are vital for efficient program implementation. These characteristics make C++ a versatile and powerful language, capable of tackling a wide range of programming tasks. So, whether you're building an intricate gaming engine, a high-frequency trading system, or a simple utility app, C++ has the tools you need. One of the key aspects of C++ is its support for object-oriented programming. But what exactly does this mean? Well, object-oriented programming, or OOP for short, is a programming paradigm that uses objects, which can contain data and methods that manipulate this data, to design and implement programs. In C++, this is achieved through four main concepts: data abstraction, data encapsulation, inheritance, and polymorphism. Let's start with data abstraction. This is the process of creating classes to describe objects. A class, in essence, is a blueprint for an object. It defines the properties and behaviors or methods that an object of that class will have. For example, if we were creating a program to simulate a zoo, we might have a class elephant with properties like age, weight, and name, and methods like eat, sleep, and play. Next, we have data encapsulation, also known as data hiding. This is a protective barrier that prevents the data from being accessed directly by the code outside this barrier. In C++, this is achieved by declaring class variables as private. Only methods that are part of the same class can access these private variables. Inheritance, on the other hand, allows us to create new classes based on existing ones. This means we can create a derived class that inherits properties and methods from a base class, allowing for code reusability and a more logical, hierarchical structure. For instance, in our zoo program, we might have a base class animal from which elephant inherits. Lastly, we have polymorphism, a Greek word that means having multiple forms. In C++, this means that a call to a function or a method will cause a different function or method to be executed depending on the nature of the call. This allows for flexibility and makes the program more intuitive and easier to manage. Through these object-oriented programming concepts, C++ allows for a more organized, efficient, and flexible approach to programming. C++ isn't just about what it inherited from C. It also brought some new features to the table. When we talk about C++, we can't overlook the significant extensions it introduced, which have contributed greatly to its efficiency and versatility. Let's start with references. Unlike pointers in C, references in C++ are a safer and more user-friendly alternative. They act like an alias for a variable, allowing us to manipulate the original data without the risk of unintentionally changing the address. This extension, while seemingly simple, has profound implications, especially when used in function arguments and return types, providing a more intuitive and safer way to manipulate data. Next up are templates. In the world of programming, reusability is key. Templates are C++'s answer to this need. These are essentially blueprints or formulas which allow programmers to write generic and reusable code. This means we can create a function or a class to work with different data types without having to rewrite the entire code for each one. It's like having one key that can unlock multiple doors. This feature not only saves time but also significantly reduces the likelihood of errors. Last but definitely not least, we have exception handling. In C, error handling was a bit of a challenge, often leading to messy and hard-to-follow code. C++ introduced exception handling to provide a streamlined, structured, and predictable way to deal with errors during runtime. This feature allows the creation of special blocks of code that will be executed when an error occurs, offering a more graceful way to handle failures and keep your program running smoothly. These extensions, references, templates, and exception handling are more than just add-ons. They represent the evolution of the programming language, bridging the gap between the raw efficiency of C and the user-friendly nature of fully object-oriented languages. These extensions further enhance the power and flexibility of C++, making it a language of choice for many programmers. As we delve deeper into the world of C++, these features will prove to be invaluable tools in your programming arsenal. So, let's recap what we've learned about C++. C++ was developed by Björn Stroustrup and his team at Bell Laboratories in the early 1980s. It's not just an object-oriented programming language, but a hybrid, incorporating the functionality of C, thus making it universal, efficient, and close to the machine. C++ supports the concepts of object-oriented programming, offering data abstraction for creating classes to describe objects, data encapsulation for controlled access to object data, inheritance through derived classes, and polymorphism, the ability for instructions to have varying effects during program execution. Moreover, C++ has been extended over time with features like references, templates, and exception handling, enhancing the language's efficiency and versatility. Despite not being a purely object-oriented language, C++ effectively combines procedural and object-oriented programming, making it a powerful tool for various platforms. With its rich history, unique characteristics, and powerful extensions, C++ continues to be a vital tool in the world of programming.